Good evening, everybody who's sitting here. Any problem, Sharan? How today? Paper discussion. Tomorrow only, next week only I start discussion. Today I'm going to give a quick recap about the whole physics. I don't know how, but let us see how. Okay, guys, I hope you are able to hear me. Dinesh, Pratap, Rohit, Dishita, Navina, everybody, please make sure that your video is on. We are going to start the class. And as I have already told in the group, in the WhatsApp group, once again I am repeating that upcoming days are going to be very, very, very crucial days. At least wherever you are standing today, from there, because we are in 12th standard, you know very well that suddenly you cannot score 8 marks, not possible. But at least wherever you are, from there you can push yourself a little bit more ahead. That is quite possible. And that is why we have decided that we are going to have full mock test from this week. And already some of you would have taken the Tuesday's mock test, where you wrote math mock test, most of you, except Pratap. To hear properly?
Sir.
Yeah.
So your video is lagging a little bit.
Video is lagging. Check. 1 second. I have connected the LAN wire also. It will take time to come from the LAN wire.
Yes.
Okay, maybe sometime it will become fine. Rohit, what about you? Are you able to hear me? Rohit, am I audible?
Sir, a bit lag is there.
A bit lag is there. What about you, Dinesh, Ashwan, Dishita, Kirti? Is it fine?
Yes, sir, it's lagging.
Lagging.
Okay, we'll see for 10 more minutes. If it's still lagging, please point it out. I will change the internet connectivity. As of now, what connectivity we are having? Let us, wait for it to become all right. I'm trying something here. But if it lags too much and you're not able to hear me, listening problem is there, something is there, you can stop my class, okay? But 5 minutes you give me for just checking whether anything can be done from our side, okay? So meanwhile, let us start the class as the plan. So I was speaking about this coming days. So hereafter, what you're going to do, you're going to write examination on all the weeks. That is 3 exams every week, 1 physics, 1 chemistry, 1 math. And the consecutive week will be the discussion class. Like whatever test you're going to write this week of physics, probably tomorrow, that discussion I will do on next Wednesday when I come with you. Okay. Then why have I called you today? Today my plan is to give a recap, not recap actually, a gist about all the chapters, right from first to the last. In this 1.5 hours of time, I'm going to tell you what to study, what you can skip, from where the marks are majority coming, which I have to focus more, which chapter has less weightage, everything I will discuss. I'm not saying that I'm guessing the question, but I will be able to give you an idea about what you should focus more and improve your scores in the board examination. This class becomes very important, and please be attentive in the class, because today I'm not going to teach anything to you. I am going to give you a quick analysis about the whole board system pattern, for which I am going to take the help of CBSE notification. Recently, I don't know how many of you noticed that, recently CBSE has released what is the marks of each chapter you are going to write in the board examination. Are you aware about this? CB itself has released. So Sharan Ram, what is the marks of electrical studies? Tell me. Yeah, you said yes, you know, right? That's why I'm asking you. This is what released by CBSE. See here. Today we are going to discuss from which chapter, how many marks, and how to prioritize your learning. Because now, school also, here also, you're writing the whole syllabus. So what chapter to focus more, where I can score more marks. Today is that day. And this chapter, what to focus more, from where the questions are going to certainly come. That's what I'll tell you. Okay, so have an eye and let us start the class today. So first of all, let me talk to you about the bifurcation. So NCERT, that is CBSE, has not divided chapter wise, it has divided unit wise. So it has told that unit 1 and unit 2 together is carrying here field, potential and capacitance and current together is 16 mark. I will also give my prediction of how much will be inside bifurcation. That is purely by my experience I am telling you. It may vary 1 or 2 marks. Don't come and scold me. You told something else happened, but it will vary only 1 or 2 marks. Don't think it will be too much different. So whatever I am going to tell today, it is going to be almost correct prediction of the bifurcation of marks. So first I am telling the CBSE given thing. So first 3 chapters together will give 16 marks. Next 4th chapter will give 17 marks, which is moving charge and magnetism, magnetism and matter, EMI, AC. Together 17 marks. Then comes the electromagnetic waves, ray optics, wave optics, 18 marks. Electromagnetic waves, ray optics, wave optics is 18 marks. And then dual nature of matter, atom, nuclei, which is the modern physics, 12 marks. And the most easiest chapter, the most smallest chapter, semiconductor, alone 7 marks. Are you seeing here? Electronic devices, 7 marks. This chapter is given to make you pass in the board examination, because it's very certain what questions are going to come from here, and they are giving 7 marks from this chapter. I think it will take 2 hours for studying this chapter for the board exam itself. That question only is there, and the maximum marks. I mean, not chapter wise, but obviously much more weightage. Now, my prediction. If I just divide all these things in my own prediction, then the maximum marks is for ray optics. No doubt in that. Now I am writing chapter rank wise. Which chapter will have maximum weightages? Ray optics. How much marks you know? I am predicting 9 marks. So out of 70 mark, 9 mark, almost 13 to 14% of your whole syllabus is going to be ray optics only in the board examination. If you are planning to skip it, you are in danger. Don't skip it. Ray optics will carry 9 marks in the board examination. First rank is going to ray optics. Second rank goes to semiconductors. Imagine. Ray optics is the biggest chapter in the whole syllabus, and semiconductor is the smallest chapter. Still it carries how much marks? 7 marks. I hope you are understanding. Then comes, let me go in order now, because everything else is 6 marks only. Okay. So I am expecting current chapter to have 6 marks. Current electricity chapter will have 6 marks. After I tell about the marks, I will tell you about what questions are going to come. That is the next talk. But first I am giving the ranks. Current will have 6 marks. Then comes wave optics. That will also have 6 marks. Okay. So after wave optics, let us talk about the next chapter. Come first. Which is moving charge and magnetism, surprisingly. So moving charge and magnetism will also carry approximately 6 marks. This is the ranking for the third rank. Third rank goes to current, wave optics and moving charge and magnetism. 6 marks each. Then comes the fourth rank, which is 5 mark. In 5 mark, you will have many things. Electrostatic potential and capacitance will definitely carry 5 marks. Probably 6 plus 5 is 11. So 5 marks will go to electric field and charges also. Obviously, yes. But you know why I am adding these chapters? Because these chapters are easy to prepare. I'll talk about that also, how to prepare for the chapter. Next, I am expecting alternating current also to have 5 marks. How much it became total? 5 plus 5, 10. 6 is 18. 49 it went. Sure, properly check, man. 5, 5, 10. 6 is 18. 18 plus 10 is 28. 28 plus 7 is 35. 28 plus 7 is 35. 35 plus 9 is 44. 44 only we have reached, guys. So 44, and I mean, this chapters alone, if you are good, no, 44 marks you have already scored. Then you can see what is there and how much marks it will carry. Second highest weightage, all the meters.
Sir, your voice is lagging.
Okay, okay. But still not that. I can plug it out and plug it in. I'm talking about that LAN wire. Whether it is okay. Try others. We can put in this system. It will be more slower, no? Isn't it? Sometimes it is faster. Okay, try. Kirti, are you able to hear me now?
Yes, sir.
Rohit, everybody, you are able to hear me?
Yes, sir.
Yeah. So I have ranked, this ranking is based upon the weightage. This is not based upon the easiness or anything. This ranking is purely based upon what? The weightage. So if you are studying based upon the weightage, then start preparing ray optics first, then go for semiconductor, and then go for all the other chapters which is having 6 marks weightage. Second way of preparation is preparing based upon the easiness. Which chapters are scoring also and easy to prepare also. I'll tell that way also to you. Okay. So in that way, if I say, start with semiconductors, which will give you 7 marks. Then go for all these 3 chapters together, modern physics, that is dual nature, atom, nuclei. 12 mark it will give you. 12 plus 7 became 19. Then you go for electromagnetic wave, it will give you 3 mark. 19 plus 3 is 22. After electromagnetic wave, you will go for electromagnetic induction and electronic current, simple chapters again. These two together will give you at least 10 marks, minimum. So 10 plus 22 became 32 marks. Then you can go for magnetism and matter, which will give you again 4 marks. So around something 30, 36, 37 you came. And then you can go for current electricity, which will give you definitely 6 marks. So around 40 we reached. So again I am repeating, if you are talking in terms of toughness and which will give me less stress to prepare, then always start from volume 2, leave ray optics and wave optics. Everything else, if you see, it is carrying 19 marks. Are you getting dual nature, atom, nuclei, semiconductor, together it carries 19 mark, and then come to electromagnetic wave, EMI, AC, and magnetism and matter. That itself will give you some solid 3 together will give you around 12 marks. And then 12 plus 12, 24, 24 plus 7, 31 came. And then you go for it. So around 36, 37 came. These are easy topics to study, where you will not spend much time. And then you can go for ray optics, wave optics, electrostatics, and moving charge and magnetism. This is for the people who want to start with easy chapters first. See, if you are aiming for more than 60 marks out of 70, you cannot skip any chapter. But today I am talking about how to start. If still you are like, I don't know how to start, where to start, then there are 2 approaches. One approach is mark-wise approach. One way is easiness-wise approach. So mark-wise approach, children, will follow this. Ray optics first, then semiconductor, then current, wave optics, moving charge, then potential capacitance, alternating current, then remaining chapters. The people who are preparing for easiness point of view, first I'll study easy chapters. They should start with semiconductors, dual nature of matter, atom, nuclei, electromagnetic wave, EMI, AC, Coulomb charge and magnetism, current, and then the remaining chapters. Is it clear? Anyhow, you have to finish all, but the order I am telling you, which will be making things easy for you. Okay. Now, let me start talking about important things from each chapter, and let me go rank wise itself. That is, first I'll talk about ray optics. It has 9 marks, right? So, which are the important questions, or from where the questions are certainly going to come? I am talking about that. That is, if you are preparing for a particular chapter, inside chapter what you should study, what you should focus more, I am going to talk about that, because big chapters are there. Study everything if you are aiming for 70 marks, but if you are aiming for, first I will aim for 50 mark, then go in this order, go in these topics first. So if I talk about ray optics, see again I am repeating, if I am going to write, I can write the whole chapter itself now for preparation, but I am focusing on important things. So out of 9 marks, 6 mark will certainly come from here. 3 mark may come or may not come. If your luck is good, whole 9 mark may come from what I am writing on the board now. Luck is bad, 6 mark will surely come. Okay. Even you can see in our papers also same will follow. In our mock test also, in school mock test also, same pattern will follow. So from ray optics, let us start what is going to be asked. So in ray optics, you can definitely expect in the board examination the question to come from refraction through spherical surface. Refraction through spherical surface. I hope you remember the formula. The formula is what? Mu2 minus mu1 by V. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. This formula, I hope you remember, mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. This formula based derivation and numerical, I am predicting it to come in the board exam itself. Check. We will have questions from here. Numericals will come, where numericals will be of this type here. Fish bowl is there, fish is there. What is the position of the image of fish? Or a particle is there, where the particle will go. Seeing from right, seeing from left, this kind of questions will come. Where mu1, mu2, U, V and R. If you are properly identifying, you will not make a mistake in numerical. Where you will make a mistake is sign convention. Be very careful about U is positive, negative, V is positive, negative, those conventions. So please practice numericals from here. Refraction through spherical surfaces. Second important topic in ray optics is lens maker's formula. Lens maker's formula. Once again, when I am saying that, what is the formula? 1 by F is equal to mu2 by mu1 minus 1 into 1 by R1 minus 1 by R2. Or instead of mu to mu1, you can write mu L by mu m also. Mu L by mu m minus 1 into 1 by R1 minus 1 by R2, where mu L is the refractive index of lens. Mu m is the refractive index of medium. R1, R2 are the radius of curvature of both the sides. It can be positive, it can be negative, it can be infinite also. That is if it is a plane side. R1 will become infinite. Remember those things very carefully. We have solved many numericals in the class itself. Check your notes and solve numericals from here. Once again, derivation and numericals. Both are important for lens maker's formula. Again, I am repeating, numericals and derivation are very important. Then third important thing from this chapter is angle of minimum deviation. Angle of minimum deviation. I am talking about the phenomena where you will write mu is equal to sine A plus del min by 2 by sine A by 2. Mu is equal to sine A plus del min by 2 by sine A by 2. I will write here itself. Mu is equal to sine A plus del min by 2 divided by sine A by 2. This formula based numericals will certainly come. And again, a very important part, which is optical instruments. I have always said this to you. Certain question in the board examination. No year you can see any paper where there is no question asked from optical instrument. Either they will ask simple microscope, compound microscope, telescope, anything they may ask you, but they will definitely ask you. So every instrument, its derivation and numericals based upon that. Are you understanding? And to some extent, I am also predicting this year they may ask a question from TIR, total internal reflection, which also includes apparent depth and real depth sometimes. But definitely TIR questions are very common in the board examination. Diagram will be given, ray will be given, and they may ask you to find something about TIR. So, if you are learning this 1, 2, 3, 4, 5 topics in the ray optics, I am assuring you 6 marks to 9 marks you can score in the board examination. Tell me, Sharan. Definitely it may come. Yes, it may come. They are asking derivation plus numerical. 5 mark question, 3 mark derivation, 2 mark numerical. Or 2 mark derivation, 3 mark numerical. It may come. Yes, it may come. But chances of numerical is more than derivation. But derivation also comes in the board examination. We cannot omit it. Okay. So these 5 topics alone, make yourself thorough first. See, because ray optics is a big chapter. Start studying, it needs at least 2 days to study ray optics itself. So if you are studying for the examination, then focus on these 5 topics first. I hope it is clear to you. Diffraction through spherical surface, lens maker's formula, angle of minimum deviation, total internal reflection, and optical instrument. Be thorough in that. Okay. Next comes the next chapter. So this whole thing we are doing for how many marks? 9 marks. So I said you from this topic I am expecting 6 to 9 marks you can cover in the board examination. Then comes semiconductors. Semiconductors is damn simple, and let me tell you how the questions are coming from semiconductors, which is once again carrying how many marks? 7 mark. CBSE itself has told they will ask 7 mark question from semiconductor. Semiconductor, the first thing is basics. When I am saying basics, it includes what is intrinsic semiconductor, what is extrinsic semiconductor, that is what is p-type or n-type semiconductor. So intrinsic semiconductor means no impurity. The conductivity is all because of the breaking of bond between the silicon atoms. We will have equal number of holes and electrons. That is all about intrinsic semiconductor. N is equal to NH. Then comes p-type or n-type. P-type is called as positive type, n-type is called as negative type. P-type is found when we are adding a trivalent impurity. Trivalent impurity like aluminium, boron, indium, isn't it? These are some trivalent impurities. If you add a pentavalent impurities, you get n-type because it becomes more negative. Examples are phosphorus, antimony, bismuth, all these things. Arsenic, isn't it? These are some pentavalent impurities. So example of pentavalent impurities. Example of trivalent impurities. How a trivalent impurity is giving a p-type semiconductor. How a pentavalent impurity is giving an n-type semiconductor. That concept is very important. So you should know very deeply when you are adding a pentavalent impurity, the phosphorus gets bonded with 4 nearby silicon, 1 electron is free, and 1 free electron is going to reside in the donor energy level near the conduction band, which increases the conductivity of a semiconductor. Same way, in p-type semiconductor, we add trivalent impurity. Trivalent impurities, for example, boron. It is going to bond with 3 silicon atoms. 1 is unbonded, which will create a hole. Every addition of boron atom gives rise to 1 extra hole. We have millions of borons, we have millions of holes. Concentration of holes is more than concentration of electrons, and holes are residing in a new energy level called as acceptor energy level near the valence band. This theory should be there in your head because any theory questions can come from here, and you can expect a question from assertion and reasoning to come from here based upon donor energy level and acceptor energy level. Is it clear? Basics, when I am saying, it also includes the definition of energy gap. It is the distance between the topmost part of conduction band to the bottommost part of the valence band, or topmost part of the valence band to the bottommost part of the conduction band. The distance is called as energy gap. Energy gap is more than 3 electron volt insulator, less than 3 electron volt semiconductor, 0 is conductor. So these basic ideas should be there. From here a question can come in the board examination. Then comes PN junction formation. Actually everything is important here. It's simple also. PN junction formation. See the whole story which should be written with proper keywords. Whenever I am talking about semiconductors, I am always using the word keywords, because keywords are very important. I have myself gone for correction. Everything will be very beautifully written, but keywords will be missing. They'll cut marks for that. Students will write blue color, orange color pen, big diagrams they will draw. 3-mark question they will write as if 2 pages, but they will get 1.5 marks only because of missing of keywords. So keywords becomes damn important if you are not using the words. For example, in PN junction formation, diffusion current, concentration, drift current, majority charge carrier, minority charge carrier, equilibrium of PN junction diode, negative and positive space charge region. If these words are missing, don't expect marks for whatever story you write inside. Keywords are damn important for the board examination. Remember that, especially for theory chapters. I am once again repeating, PN junction formation takes place when P and N are connected together. When P and N are connected together, there is a diffusion of electrons from N to P and holes from P to N due to the change in concentration. This gives rise to diffusion current. Diffusion current gives rise to negative and positive space charge region, which is going to give rise to depletion layer. Depletion layer will not allow the movement of majority charge carriers, rather encouraging the movement of minority charge carriers. Then we will have a current called as drift current. Initially drift current is very low, diffusion is very high. Slowly drift current is going to increase, diffusion is going to reduce. At a point where drift current and diffusion current becomes equal, we reach to the equilibrium of semiconductor device, and at that point net current becomes 0. This story, if you are writing properly in technical words with proper keywords, you will get full marks. It's important. Okay. Then comes the biasing. When I say biasing, there are 2 possibilities: forward bias and reverse bias. So decrease in depletion layer because of the semiconductor being forward bias, and increase in depletion layer because the semiconductor, that is PN junction, being a reverse bias. Story about that. When forward bias happens, how depletion layer is reducing. When we are reverse biasing, how depletion layer is increasing. How a diode is failing in reverse bias. What is the meaning of avalanche voltage? These basic, again, keywords are very important. And then obviously, very important thing is PN junction, or I should write like this, VI characteristics. VI characteristics of a PN junction diode. PN junction diode. I am talking about this graph. I hope you know this graph, isn't it? Very important. This is a forward bias graph. This is a reverse bias graph. How it happens, what happens, the story behind that. Always remember that. Here it will be in which amperes? This side you will have milliampere, one side you will have microampere. In reverse bias we have current in microamperes. In forward bias we have current in milliamperes. Here you will have voltage in 0.5 like that, less division. Here you will have voltage in more values, 30, 40, 80, 50 volts like that. So that things you should be remembering. Check the book, NCERT is very beautifully given that VI characteristics of a PN junction diode is very important. Also dynamic resistance, del R, dynamic resistance. Ohm's law only will give resistance V by I. In the case of semiconductors, we will have only dynamic resistance, it will be del V by del I. So here we will not have same resistance throughout, it will be keep on changing. If you have conductor, it follows Ohm's law. If it follows Ohm's law, its V by I will always be a constant, R. But if you are having a semiconductor, it will not follow Ohm's law. Here you will have del V by del I as del R. It is called as dynamic resistance, where resistance keeps on changing with time. Okay, that is about the VI characteristics of PN junction diode. And finally, the half and full wave rectifier. Some of you may think, sir, everything you wrote, what you left then? Everything you wrote, only full chapter you wrote. Man, 7 marks it is giving you. You cannot skip anything from here. 7 marks it is giving you. I cannot select some topic from here. It will reduce 2 or 3 marks. And simple chapter also. Why I should leave something from here? So if you study all these, once again 5 topics only. Study these 5 topics, assured 7 marks is there for you. That is knowing about the biasing, knowing about the VI characteristics, knowing about half-wave and full-wave rectifiers, knowing about the intrinsic semiconductor, extrinsic semiconductor, P-type, N-type, etc. energy level, donor energy level, junction formation, enough to score marks in the board examination. Is it clear? So 7 marks from where is going to come, I have told here. Focus on these topics. Please. Then comes the third important chapter. So as per the prediction, third important chapters are 3. Current, moving charge and magnetism, and wave optics. Let us go in the same chapter wise order. That is, let us talk about current chapter, what is important. Current electricity, which carries almost 6 marks in the board examination. What are the important topics and how to prepare for it? In current, the first and the most important thing is drift velocity. I hope you remember that. I is equal to NEAVD, isn't it? This formula, this derivation, numericals based upon this, everything is important, especially theoretical questions from here. So, how this derivation was made, I have told very clearly to you. Remember the class, I have told you I is equal to, first you have to find what is the net current. Net current will become equal to 0 initially. Then you apply a external voltage. Then the net current becomes V and it will be drifted. Force will act on it. Force will become equal to mass into acceleration. It will become equal to Q into E. From there you will get the acceleration as QE by M. And then you will have, that is minus E by M. And then you will have V is equal to U plus AT. We will find V1, V2, V3 and we find V average. And that average velocity of all the electrons with which it is drifted after external potential is applied to it is called as drift velocity. I will repeat this. Average velocity with which the electrons are drifted after a conductor is connected with the external potential, that velocity is called as drift velocity. And relaxation time is the average time between successive collision of the electrons. Drift velocity formula is minus E tau by M, and tau is called as average relaxation time, which is T1 plus T2 plus T3 plus T4 plus T5 by 5. That is called as average relaxation time tau. So minus E tau by M gives you drift velocity, and I is equal to NEAVD gives relationship between current and drift velocity. This topic becomes very, very important for the board examination. Next important topic from this chapter is temperature dependence of the resistance. Temperature dependence of resistance and resistivity. That is, rho is equal to rho naught into 1 plus alpha T minus T naught, or R is equal to R naught into 1 plus alpha T minus T naught. That is here rho T or RT, whatever. This formula based numericals are very, very important. Numericals, if it is going to come, it's going to come from this topic. Remember that. Those formula based numericals are very important. No derivation, only numerical will come from here. So please prepare that properly. Numericals based upon temperature dependence. Then important topic from this chapter is cells in series and parallel. I have taught this to you very deeply. I have taught you, where I have made you understand when cells are connected in series, then the net EMF is the algebraic addition of each EMF. That is E1 plus E2 plus E3 plus E4 plus E5 is E net for series connection. Same way, internal resistance is R1 plus R2 plus R3 plus R4. If one of the cells is connected in the opposite direction, that is, if you have plus minus plus minus plus minus minus plus, then that cell will become negative E. That is E1 plus E2 plus E3 minus E4. But R1 plus R2 plus R3 plus R4 only will be there. So always internal resistance is added however the cell is connected, but EMF may be subtracted if one of the cells is connected in the opposite direction. That is for series connection. Parallel connection, I told you, 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4, and E equivalent by R equivalent is equal to E1 by R1 plus E2 by R2 plus E3 by R3 plus E4 by R4. It means if you want to calculate the equivalent EMF of cells in parallel, you cannot find without finding the R equivalent, because the formula is E equivalent by R equivalent is equal to E1 by R1 plus E2 by R2 plus E3 by R3 and so on. But in series connection, E equivalent is E1 plus E2 plus E3 plus E4. So you can find the value of E equivalent in series connection just by knowing the individual EMFs, but you cannot find the equivalent EMF in parallel without knowing the internal resistance equivalent. Remember this in your mind. Questions may come from assertion and reasoning, where they may ask you, when do we go for series connection and when do we go for parallel connection? Always remember that we go for series connection when external resistance is much bigger than the internal resistance. And when do we go for parallel connection? When internal resistance is much bigger than the external resistance. These kind of questions, theories will come from cells in series and parallel, which also includes the formula V is equal to E minus IR while discharging, or V is equal to E plus IR while charging, where V is called as terminal voltage, I is the net current, small r is internal resistance, V is equal to E minus IR or V is equal to E plus IR. Formula is also very important. Then comes the Kirchhoff law and the Wheatstone bridge. That's all. Kirchhoff law, both the laws. Remember that junction law is based upon law of conservation of charge, and loop law is based upon law of conservation of energy. This question very frequently comes in MCQ category. And then numericals based upon that. Very important. Numericals based upon Kirchhoff law. It's not like it is certainly going to come, but definitely if it comes, it can kill your time if you are not strong in numericals from here. So numericals based upon Kirchhoff law is very important. And again, Wheatstone bridge, numericals as well as derivation. Derivation plus numerical is very important for the Wheatstone bridge. So if you are preparing current chapter, make sure these 5 topics you are thoroughly undergoing. There are many things else in this chapter, but I am focusing only on the important things. Drift velocity concept, Taylor dependence concept, cells in series and parallel concept, Kirchhoff law based numericals, and Wheatstone bridge derivation and numericals is important for the board examination. Then comes the next important 6-mark chapter, which is moving charge and magnetism, before I go to wave optics. So let me go to moving charge and magnetism, which is a 6-mark weighted chapter, moving charge and magnetism. So from here, once again, what are the important topics from where the questions are coming? So you can remember that questions can come from magnetic field due to circular current carrying conductor. Circular wire I am writing. That is axial point and central point. I hope you remember the formula. So magnetic field here is equal to mu naught I a square by 2 into a square plus r square power 3 by 2. And if it is central point, then the magnetic field is mu naught I by 2r. So these formula, derivation as well as numerical is very important. Derivation also is important, remember that. Okay. And numericals certainly going to come, certainly. Check it out. In the board examination, expect numericals to come from circular wire, where they may give condition like this, or they may give condition like this, or they may give condition like this. Anything they may give you. circular wires are there, they may ask you to find magnetic field here, 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 anywhere they may ask you. Only if you understand how it functions, you can answer this kind of question. Otherwise, the questions can be like this: finding the magnetic field at the center, finding the magnetic field for this particular center. Like this, many questions can come. It's very simple questions, believe me. All these are very simple. Looks complicated, but actually it's simple questions. If you are knowing the concept of circular current carrying conductor, mu naught I by 2 r how it functions, mu naught I a square by 2 into a square plus r square power 3 by 2 how it functions. All these numericals are simple, very simple from you. Don't forget it has vectors also. Okay. Next comes in this chapter the important thing, which is talking about the force on a moving charge. Force on moving charge kept in magnetic field. Once again, big chapter, I am just taking out the important things. See, I'm repeating, it's going live, it is recorded. I am not saying learn only these topics. Learn the whole syllabus. But these topics are more important. Don't come and say me, sir, you told this only is enough. I'm never saying that. I am giving you important topics from each chapter. But I highly recommend to learn all the topics in the board examination. Okay, coming back. So force on a moving charge kept in a magnetic field, that is F is equal to QEB sin theta. Based upon that, we have no R is equal to mv by qb, T is equal to 2 pi m by qb, nu is equal to qb by 2 pi m. Remember these things. That is finding the radius, time period and frequency of a charge moving in the magnetic field. When the charge enters the magnetic field perpendicular to it and at a random angle theta, where you will have pitch, helical path. That is, in that case you will have R is equal to mv sin theta by qb, T and nu will remain same, pitch will come 2 pi mv cos theta by qb. So all these derivations and definitely numerical analysis question based upon that. The questions will come like hydrogen and helium, alpha particle and hydrogen. They are entering the magnetic field, which will have a greater radius, which will have a smaller time period. They are comparing helium or doubly ionized helium, alpha particle, hydrogen. So when they are giving some charge to you, indirectly they are giving you the value of Q and M. Compare that and solve and get which will have more radius, which will have more time period. That numerical is definitely very important. Numerical means questions based upon analysis, theory questions will be there. It is very important. That is the radius, time period and frequency of all three, even pitch of charge entering perpendicular or charge entering randomly. Tell me, Sharon. Derivation rarely comes, but definitely numericals will come from it. Numericals means not value based numericals, comparison based numericals, where they will give you 3 particles are entering the magnetic field, which will have higher radius. Okay. Sometimes they will compare based upon the kinetic energy. Don't forget that. If the formula is R is equal to mv by qb, it is valid for which condition? Only for velocity comparison. If you want to convert into kinetic energy formation, how you should convert? C. R is equal to, here mv is there, no? If I want to convert mv into kinetic energy, I should multiply, 1 by 2 and divide 1 by 2 and multiply 2, right? And I have to make mv square, isn't it? So I want to write 1v above, so I have to add 1v below. Are you understanding my point or not? Now this becomes half mv square. What is that? Kinetic energy. So R will become 2 times of kinetic energy divided by Q into V into B. Now once again velocity is there. Velocity has to be changed into kinetic energy format. Are you getting? So what is kinetic energy? Kinetic energy is equal to half mv square. So what will be V? V will be 2 kinetic energy divided by m root over, isn't it? Put that here. So we will get R is equal to 2 kinetic energy divided by Q B. Instead of V I am writing root of 2 kinetic energy. Above you will have root of m. So if you this root 2 will cancel and make it this root 2. you will finally have root of 2m kinetic energy divided by qb. Now you can compare two charges entering the magnetic field with same kinetic energy. See guys, there is a difference. When you compare these two, I mean by using this formula, it is R proportional to mass. When I am using this formula, R proportional to root of mass. They both are not same. Many students are missing marks in this. When you are comparing, you are thinking same velocity, same kinetic energy, and comparing directly by mass, R is proportional to m. If mass is double, R is double. No guys. If mass is double, R is double if velocity is same. If mass is double, R is root of double, that is 1.41 times only, 414 times only, if it is same kinetic energy. Are you understanding my point or not? If they give you two particles enter, one particle is having double the mass of another, they both enter the magnetic field with same velocity, what will be the ratio of the radius? Answer is 1:2, because double the mass means same velocity, you know. Double the mass, same velocity, it means what? M, it is proportional to m. Double mass will have double velocity, double radius. So we will say 1:2 ratio. If they say you two particles are entering the magnetic field in such a way that they are having same kinetic energy and one particle is double the mass. So in this case, R will become proportional to root of m, isn't it? If it is root of m, it will be 1:√2 as the ratio, not 1:2. I hope you understood what I am trying to say. This kind of questions can make you lose marks. That's why I am stressing this point and teaching these things. These things are important. Then in this chapter, expect the question to come from force between two parallel current carrying conductors, current carrying wires. This one. If they are carrying current in the same direction, they will attract each other. Opposite direction, they will repel each other. This force per unit length is equal to mu naught I1 I2 by 2 pi d. D is the distance between them, isn't it? This formula F is equal to mu naught I1 I2 by 2 pi d is damn important. See the board papers, you will understand. Many numericals are coming from here. Many numericals are coming from here. Check your board papers.
Sir,
Yes, tell me, Pratap.
today in our school revision, we had one question like there was one wire and then there was a coil, sir. Basically, the wire, the two sides of the coil were considered as two different straight wires, sir. And then we did that problem.
Are you talking about this kind of question you're talking?
Yes, sir.
Yeah, this is a very common question, where one wire will take a current like 2 ampere and Kirchhoff law. Are you saying Kirchhoff law, man?
No, sir, no. This force per unit length only.
Yeah, exactly. So here if you see, these two wires are parallel having current in same direction. They will attract each other, isn't it? This wire and this wire are carrying current in opposite direction. It will repel each other. So net force will be this force minus this force. So you will find F1 first by these two wires. Then you will find F2 by these two wires. And then you will do F1 minus F2, you will get the answer. I hope you are getting this. Right? So F1 and F2 you are going to find by mu naught I1 I2 by 2 pi d concept, and based upon that you are going to get the force, net force on the wire. Moreover, definition of 1 ampere of current is also very important from here. Sometimes a numerical is given and then they write second part of the numerical is define 1 ampere of current from here. So 1 ampere of current is the current flowing in two wires when they are kept unit distance apart and having unit length if the force acting between them is 4 into 10 to the power minus 7 Newton. Isn't it? I have taught this to you in the regular class. Check your notes. So when the force between the two wires of unit length having unit separation carrying unit current, that is only 1 ampere. If the force between them is 4 into 10, 2 into 10 power minus 7 newtons, then they are going to have 1 ampere current. That is the definition of 1 ampere of current. Very, very, very important again. And then in this chapter, actually the page is becoming a little short. So in this chapter, what is important? Let me erase some part and write it here. I have taken some space here for radius thing. Yeah. So you can expect the questions to come from, yes, yeah. So questions you can expect to come from MCG, where you should know that deflecting torque, restoring torque, and then talking about the equating both and writing current is depending upon the theta. And then the conversion. How do you convert a galvanometer into ammeter and to a voltmeter? Ideal ammeter has zero resistance. Ideal voltmeter has infinite resistance. If you want to convert a galvanometer into ammeter, connect a shunt in parallel. If you want to convert a galvanometer into voltmeter, connect a high resistance in series. So all these concepts, the derivation part of it, and numericals based upon this. So conversion, again I am repeating, derivation and numericals are very, very important from this chapter. This chapter actually is very long, very big, not deserves that much, time for the 6 marks only. But if you are preparing for 100 marks, then you should prepare this chapter also. And I have done only few parts. Many things I have left itself in this chapter. Then also this looks very big. But I like this chapter. If you ask me, my favorite chapter in the whole physics is this chapter only. Out of all the 14 chapters, my favorite chapter is this chapter only. I like this. I don't know why. But if it is troubling you, you can think of skipping it if you are preparing for only passing. If you are preparing for highest marks, then this chapter is very important. Coming back. Next 6 mark chapter. So we have taken 2 6 mark chapter already. Next 6 mark chapter that I told, which is going to come in the board examination, is wave optics. So from wave optics, what to study and how to not lose marks in wave optics. Let us talk about that. So wave optics, which we are expecting to carry 5 to 6 marks in the board examination. So what are the important topics from wave optics? So from wave optics, the first and the foremost, the question is going to come from wavefront shapes. A point source having a spherical wavefront. Light coming from infinite source having plane wavefront. Rays passing through convex lens going to have plane wavefront and spherical wavefront. Light passing through prism, plane in different directions. All these diagrams are very important. Sometimes they are asking you just the shape of wavefront for a given light conditions. Okay, very important for the board examination. After knowing what is the wavefront shapes, derivation, that is laws of reflection and refraction based on wave optics. I have told you many times in the board exam, they will give you half diagram and they will write complete the diagram and derive the laws of refraction. So I hope you remember the refraction derivation. By diagram only you can derive properly. Draw the incident wavefront, draw the refracted wavefront, then 2 triangles, one triangle, this another triangle, make it prove congruent. After proving congruency, by CPCT, angle I is equal to angle R. For refraction, take one triangle, another triangle, sin I, sin R, ratio constant. That's all. If you remember these 2 things, you will not make mistake in laws of reflection and refraction by using wave optics. It's very important. Once again, I am expecting question to come this year from here only in the board exam also. But anyhow, we cannot be certain, but questions are frequently coming. Next thing is about the concept of constructive interference and destructive interference. When I say this, I want you to remember that resultant amplitude is root of A1 square plus A2 square plus 2 A1 A2 cos phi, and resultant intensity IR is I1 plus I2 plus 2 root I1 root I2 cos phi, where phi is called as a phase difference, and phase difference depends upon the path difference by k delta x times, where k is called as propagation constant. Its value is 2 pi by lambda, so phi is equal to 2 pi by lambda into delta x. Sometimes in the examination they will give you phase difference. One question one day Kirti asked me, remember the question? There they gave indirectly the path difference they gave you from lambda by 6, something like that, if I remember the question. From path difference we have to find the phase difference, and from phase difference we have to find the intensity or amplitude. This kind of questions are very common in the board examination. They will give you, there are two waves having a path difference of lambda by 6. What will be the amplitude of the resultant wave if they are having same amplitude? That is A1 is equal to A2 is equal to A they gave, and lambda they gave indirectly, that is delta x they gave, lambda by 6. Now if you put delta x equal to lambda by 6 here, lambda gets cancelled, 2 pi by 6 will become pi by 3, and phi you got, put the value of phi here, get the answer. These kind of questions are frequently asked in the board examination also, where they are indirectly giving you the value of phi by giving delta x. And when I taught, once again, when I have taught you wave optics, I have taught this full of my heart, too much energy I have spent. I remember I have given you proper explanation about everything I explained to you. Check the class videos also. There I have told you which points constructive interference, which point destructive interference, which path, which everything I told you. If phase difference is 0, 2 pi, 4 pi, 6 pi, 8 pi or 2n pi, constructive interference. Path difference is 0, 1 lambda, 2 lambda, 3 lambda, 4 lambda, constructive interference. If phase difference is pi, 3 pi, 5 pi, 7 pi, 9 pi, odd pi's, destructive interference. If path difference is lambda by 2, 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, you have destructive interference. So why destructive, why constructive, everything I have explained very deeply in your regular class itself. So expect questions to come from here. And then YDSC based numericals and derivations are important. Derivation and numerical. And diffraction, no derivation, only numerical. I have taught derivation also to you. I have spent one full day to teach you diffraction, but not required for the board examination. Just to make you understand diffraction, I taught all those things. But for the board examination, just remembering the formula, location of nth bright, nth dark, n lambda d by d for YDSC, brightness, 2n minus 1 by 2 lambda d by d for destructive interference. So all those derivations and the numericals based upon it is important, including the fringe width, and obviously the graphs are important, guys. Graphs of YDSC will have same amplitude, graph of diffraction will have decreasing amplitude becoming 0 at the last. Again important for the board examination, they will ask directly draw the diagram of the graph. So graph for diffraction will be fading out like this, it will die off, and in YDSC it will have same heights, so intensity versus phase difference graph. That is all about wave optics. Once again, wave optics, if you are understanding well, is a scoring chapter. Compare moving charge and magnetism. So many topics are there, 6 marks only. Here, just knowing law of reflection refraction, YDSC diffraction, you are going to get 6 marks. So if you are understanding wave optics, it's a scoring chapter for you. Mind my words. Coming back. So we have done all the 6 marks discussion, that is current, moving charge and magnetism and wave optics. Let us come to 5 marks now. I said 5 marks are two chapters I have given here, alternating current and electrostatic potential and capacitance. So I will go with alternating current first. Alternating current, which will carry 5 marks. Again, my prediction. if I talk about alternating current, once again, those who are understanding alternating current know it's very simple chapter for them. Very simple chapter. And if you're confused, it is confusing obviously. So the first thing which you should understand is RMS value of AC current, which is I RMS is equal to I naught by root 2. This derivation is very important, guys, where you will take the DC current, pass through a resistor, you will find the heat energy, then you will pass AC current by use integration and all these things, find the heat energy, equate both heat energy, and you will get the value of I RMS is equal to I naught by root 2. 0.707 times of I naught is I RMS. So derivation is very important. If you have missed my class of derivation, check the video, it is there in the app already, where you can get the derivation of RMS value of alternating current. Okay. Then comes purely resistive circuit, purely inductive circuit, and purely capacitive circuit connected to a alternating current supply. The most easiest thing, scoring thing, if you know that. E is equal to E naught sin omega t, I is equal to I naught sin omega t. E is equal to E naught sin omega t, I is equal to I naught sin omega t plus pi by 2. Isn't it? For inductive circuit, it is plus pi by 2 or minus pi by 2? Minus pi by 2. For capacitive circuit, E is equal to E naught sin omega t, I is equal to I naught sin omega t plus pi by 2. Moreover, what you will forget, I will tell you, you will forget derivation of it. In the case of capacitive circuit, we take I is equal to dq by dt and q is equal to CV. From there we derive it. In inductive circuit, we are taking the help of E is equal to minus L into di by dt. From there we will integrate and derive I. In one case, I am converting cos theta as sin 90 plus pi by 2. In one case, I take sin 90 minus pi by 2. Be careful about that also. Derivation part, again, I have taught in the class very deeply. Go and see the video if you have not missed the class, or if you have notes, read the notes. That is for these three circuits. Very, very, very important and very, very simple also. Then comes series LCR circuit and resonance. Series LCR circuit and resonance. Very simple again. Just by phasor diagram. Just by phasor diagram, you can draw the purely resistive circuit, inductive, capacitive, assuming predominantly inductive or predominantly capacitive. You can do derivation. Impedance Z will become equal to root of R square plus XL minus XC the whole square if it is predominantly inductive, or XC minus XL the whole square if it is predominantly capacitive. Isn't it? Resonance condition is when Z becomes equal to R, that is when XL becomes equal to XC. XL is omega L or 2 pi nu L. XC is 1 by omega C or 1 by 2 pi nu C. If you equate omega C to omega L, then you are going to XC to XL, you are going to get omega R, which is called as resonating frequency, which will become equal to 1 by root of LC, or nu R, which is going to be 1 by 2 pi root of LC. That is the resonating frequency, omega or nu. Again, important. And believe me, you will have numericals from here. And if you are not knowing this kind of questions where they will give you something like this, E is equal to 200 sine 50t plus pi by 2, like this they will give you. So when they give an equation to you, compare with E is equal to E naught sine omega t plus phi, you will get everything. You will get the value of E naught, you will get the value of omega, you will get the value of phi. Are you understanding? So now very clearly we can see this circuit must be a capacitive circuit. Actually E is given, and based upon E is the plus means it will be inductive circuit actually. And then E naught is given, omega is given. If omega is given, omega is 2 pi nu. You can easily find frequency also. If you divide E naught with R or XC or XL, you will get current also. Or impedance, you will get current also. Are you getting a point? Current will become equal to EMF by resistance. It can be resistance, it can be XL, it can be XC, it can be Z. Anything it can be. If it is inductive circuit, it will be XL. If it is capacitor, it will be XC. If it is LCR, it will be Z. If it is purely resistive circuit, it will be R. So remember that numericals coming from here, numericals coming from the equation. And the last and the most, again not most but important, which is what is it? Power. That is called as power in a circuit. P average is equal to ERMS, IRMS, cos phi. I hope you know that. Where cos phi is called as power factor, P average is the, what is P average? P average is called as the real power. And this ERMS into IRMS is called as apparent power. So when apparent power is multiplied by the power factor, then we get something called as real power. And once again, derivation of it and some numericals also may come here. One more thing is cos phi is equal to R by Z. Don't forget it also. So this is all about the alternating current chapter. If you are undergoing all these topics, then you are done with alternating current. Yes, man, forgot. Thank you. Because transformer, one question is certainly going to come in the board exam. One important topic I forgot. Transformer. Yes, very important. One numerical will certainly come, and scoring numerical, where you should know how to make step up transformer, how to make 17 degree is there from that time. You should tell before, no time is going to go over also. The transformer is electrical device which is used to which is used to increase or decrease the voltage. Step up means it will increase the voltage, step down means it will decrease the voltage. In step up, principle of transformer also, based on mutual inductance. And in step up transformer, we have more turns in secondary side. In step down, we have more turns in primary side. And the formula of transformer ratio, NS by NP is equal to ES by EP is equal to IP by IS. That formula and numericals coming from there. Many times you will see a case study question coming from transformers. Have you seen it? So AC sometimes, not sometimes, many times, out of 5 mark, 4 mark will come in the case study itself. And 1 mark will come in some numerical MCQ. Are you getting my point? So 4 mark generally from AC will come in a case study type question where they will ask transformer to you, or sometimes they may ask you LCR circuit to you. Here are the questions are coming from here. I hope it is clear. Next 5 mark question I told is from electrostatic potential and capacitance, isn't it? Let me talk about that. Electrostatic potential and capacitance. What is going to be asked from here? This chapter, if I am dividing into 2 parts, one part is about electric potential, where you have V is equal to KQ by R derivation. Then you have potential due to a dipole at axial point, equatorial point, isn't it? And at random point also. So V is equal to Kp cos theta by R square for random point. V is equal to 0 for equatorial point. And V is equal to Kp by R square for the axial point. You remember all these things? So potential due to dipole at all the points, axial, equatorial and random, is important, where V is equal to Kp cos theta by R square is for random point, 0 for equatorial point, and Kp by R square for axial point. Then you have V due to spherical shell. This question also I am seeing very commonly coming. That is outside Kp by R square, on the surface Kp by radius square, inside the shell also Kp by radius square. It is important, and the graph based upon it. This is the graph for this, where up to the radius R becoming equal to radius, it will be same, then you start decreasing. I am talking V versus R, a graph, potential versus distance. So it's important for the board examination. Then comes potential energy. Potential energy of dipole kept in uniform electric field. That is U is equal to P cos theta 1 minus cos theta 2. From there only you get minus P cos theta. If you assume, what you assume that theta 1 is equal to 0 and theta 1 is equal to theta. 0 means 90 degree for the maximum torque. So that U is equal to minus P cos theta. If it is going to be negative, it is going to be stable equilibrium. If it is going to be positive, it is going to be unstable equilibrium. It is going to be 0, it is going to be neutral equilibrium. So positive, negative and neutral equilibrium also is important from this thing. And the last part of this topic, that is half of this chapter, is about the potential energy and potential numericals. What I am meaning, I'll tell you. They'll ask a question like, charge is here, charge is here. What is the work done to move a charge from here to here? So you will find the potential at this point. Potential at this point will be V1, it will be V2. Find potential difference V1 minus V2 and then multiply by charge. You will get work done. Because potential is work done per unit charge only. So when you multiply charge with potential difference, you get the work done. That kind of numericals are going to come in the examination, where you have to find V1, you have to find V2, subtract both, you will get potential difference, multiply potential difference with the charge, you get potential energy. So that based numericals are important from electric potential. And then comes the next part of this chapter, which is capacitors and capacitance. From here, what is important? Important is capacitors in series and parallel. So when they are in series, 1 by C series will become equal to 1 by C1 plus 1 by C2 plus 1 by C3, and C parallel is equal to C1 plus C2 plus C3. Numericals based upon that also comes. We'll give a diagram to you and they'll ask you to find the equivalent capacitance. That kind of numericals are also important for the board examination. Then comes the derivation of capacitance due to parallel plate capacitor with or without dielectric, where the formula is epsilon naught A by D minus T plus T by K. This derivation is very, very important. Very, very important. That is parallel plate capacitor with dielectric inside. So how this derivation is done, please go through it. And nowadays I am seeing some questions coming from energy also. Energy means U is equal to half CV square. Based upon that, some questions are going to come. So that is all about important topics from electrostatic potential and capacitance. See, we have so many things I have not talked about. Polarization is there, principle of capacitance is there, spherical capacitor is there. Nothing I have touched now. Because once again I am repeating, I am taking the important things from where the questions are mostly coming in the board examination. Okay, that is about the second chapter. Let us go to the next important chapter. All the main chapters I have done actually. All the 9 mark, 7 mark, 6 mark and 5 mark I have touched. What remains from first volume is 2 chapters. 3 chapters actually. First chapter, EMI, electromagnetic waves. In second volume, yeah, 4 chapters are remaining. And next chapter, what is remaining? Dual nature, atom, nuclear. Okay. So first I will talk about volume 2 because 12 marks are there and simple chapters are there to explain you. So if I talk about the modern physics, when I am saying modern physics, I am including all 3 chapters together, which are dual nature, atoms and nuclei. Totally it carries how much marks? 12 marks. All 3 chapters together. So first I'll talk about dual nature. So from dual nature, what is going to come? In dual nature, the first important topic is the graphs for photoelectric effect. that is Halbeck and Lennard experiment graphs. There are 3 graphs, right? The first graph, 4 graphs actually. First graph is like this, the graph between photoelectric current and intensity. The second graph is like this. This is the graph between photoelectric current and voltage. Third graph is like this. Isn't it? This is the graph between voltage and photoelectric current. And the fourth graph is like this. Stopping potential and the frequency. So this graph tells about when the intensity of the incident radiation is increased, it increases the photoelectric current in the same ratio, that is directly proportional. It means more intensity of incident radiation means more number of photoelectrons emitted per second. This graph means that, this graph tells you one thing, that EV naught is equal to half mV max square, which means that for same intensity, if same frequency, if you have various intensities, then the energy required to stop photoelectric current will be same. Since frequency of incident radiation governs the maximum kinetic energy possessed by the, intensity will govern only the photoelectrons emitted, and frequency only governs the maximum kinetic energy, which is obviously governing the stopping potential also. And this graph says that different metals will have different threshold frequency, and once threshold frequency is reached only, the photoelectric effect will start. Before threshold frequency, photoelectric effect will not start. That is about this 4 graphs. Definitely question will come from here, for sure. Then in this chapter, important thing is about de Broglie's wavelength, lambda is equal to h by mv, or lambda is equal to 12.27 by root v naught for a moving electron. So that based numericals, or that based derivation may come. One more formula I give you, remember, lambda is equal to h by root of 2m e v naught, or 2m kinetic energy, whatever you want to write. So that is also very important for the board, isn't it? So these things is for dual nature of matter. I am talking about the important things from dual nature. Then comes atoms chapter. So from atoms chapter, what is important? First thing is all the models. For example, let me not talk about the Thomson's model much. Let me talk about Rutherford's model. So for Rutherford's model, what is important? Its postulate, isn't it? Its limitation. Then what is important is distance of closest approach. Very, very important. Remember that. So from here only, we are going to have the derivation part of it, where you will derive what is the value of distance of closest approach. Remember, it's very important for the examination. Then you are going to talk about the Bohr's model, where when I'm saying Bohr's model, once again its postulate, limitation, and the derivation of radius and velocity is very important. Also energy, 3 things. Radius, velocity, energy. When I'm saying energy, kinetic energy, potential energy, total energy. That thing is very, 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 very important. Energy is the most important part actually. Remember that. Energy is the most important part of the Bohr's model. And obviously for Bohr's models, the postulate of it, limitation of it is also equally important. This is for the atoms chapter. Then after this, this thing, you have the spectra, that is talking about energy. E is equal to minus 13.6, no, by root
6, sir.
13.6 by root by n square, I think.
N
Not
square,
by,
sir.
by n square electron volt, isn't it? This is the formula of energy by which you can find the energy of each level. Yeah, tell me, sir. numerical will not come, theoretical questions may come from there, where you have that Bohr's quantization condition, where we say that the electrons will choose to move only in the orbits where the angular momentum is interior multiple of h by 2 pi. It is L is equal to nh by 2 pi. Based upon that, theoretical questions will come, numericals will not come. Numericals will come only from here, energy, where they may ask you if electron is jumping from second to first, third to second, what will be the emitted radiation. How you to find that? You have to find the energy, and then based upon the energy, where to where it is jumping, it decides. Balmer series, Paschen series, bracket series, P1 series, isn't it? Different energy, you know that for first Lyman series, what is the emission? UV. Lyman is first, right? After Lyman, what is there? Balmer. What is the emission? Visible. After that, what is there? Paschen, infrared. Bracket, infrared. Infrared. Isn't it? So you have to remember by which to where it is jumping, what kind of emission is there. So the questions based upon that also may come. Then comes the last topic of modern physics, which is the nuclei. From nuclei, you have to be very clear in what is nuclear force. You should know what is the binding energy and binding energy per nucleon. Recently, I have taught this chapter. The video is there in the app. If you want to recall, you can recall there also. Nuclear force talks about the graph. You remember this graph? Nuclear force graph is like this. Like this. Very important graph for the board examination. Then binding energy graph also is there. You remember? Like this. Very important. Where iron is having the highest binding energy, 8.75 or 8.65, something like that. So iron has very high binding energy per nucleon obviously, and uranium is having less. That is, all the elements from 30 to 170 are stable. Mid-sized nuclei is stable, below 30 unstable, above 170 unstable. And how the instability is used to gain the binding energy release. That is fission and fusion. That is also important in this chapter. The fission reaction and the fusion reaction. Again, very important questions will come from here. That is how a uranium is breaking into two mid-sized nuclei. It can be anything, strontium, krypton, anything it can be. So all three reactions where the three neutrons are released, 4 are released or 2 are released. Remember the equation. And for fusion, hydrogen becoming helium, tritium becoming helium, all these things, remember the equations. So if you remember the fission, fusion, binding energy, the curve and also the numericals. So from numericals, how will you find? Which formula you will use for numerical? Numerical formula is ZMP plus A minus Z into Mn minus N of the M of the nucleus. That is mass of the nucleus will give you what? Delta M you will get. And multiply delta M with C square, what you will get? Binding energy. Divide this delta M into C square by total number of nucleons. You will get binding energy per nucleon. Numericals will come from here. One thing, when you are finding mass defect in terms of AMUs, just multiply with 931.5, directly you can get in mega electron volt. After that, divide with mass number, you will get binding energy per nucleon. It's very simple. Okay, that is about modern physics. I could not take some chapters, important topics, which I will do in the next class if you permit me. But most of the chapters I could, that is 12 marks plus 5 marks, 17 marks. 17 plus 5 is 22, 22 plus 6 is 28, 20 plus 6 is 34, 34 plus 6 is 40, 40 plus 16 is 40 plus 16 is 56. So out of 70, 56 marks I have discussed today with you. Remaining 14 marks are from moving charge and magnetism, electric field and charges, not moving charge and magnetism, magnetism and matter, electromagnetic waves, and EMI, electric field and charges. See, 4 chapters giving you only 14 marks. So I went in the priority order, which will have less study and more marks. So again, I am repeating today, whatever I have taught, take it very seriously and don't miss the examination. Still some of you are missing it. And once again, I am repeating, those who are writing in online mode, until you are writing in front of the camera, we are not considering it for correction also. So whenever you're taking a test, always take the examination in front of the camera. You are allowed to change the question paper also. That is right, physics instead of chemistry, chemistry instead of math, allowing that. But without coming in the camera, we are not allowing to write the test. So please take it seriously. And next Wednesday when I come, I'll come with a paper discussion of this week's test, 70-mark test. Okay. All the best. Do well. We'll meet on next Saturday, next Wednesday. Take care. Bye-bye.
Thank you, sir. Bye.
Girls can move first, then boys will follow next.